Hello everyone, this is Sudesh. I lead the CSA San Francisco chapter along with Satish and Mega and others. And this is also one of the CSA chapter meeting. And today we have two amazing presenters. The first presenter is Yamnish Kanaparthi, and Yamnish is going to talk about the machine learning for threat classifications. And then we have another presenter, Patrick. Um, Patrick is going to talk about the EPSS product from company called as Nuclei to give further insights. So without any further ado, I will hand it over to Yamnish.
Thanks, Sudesh. Let me also get started by sharing my screen. Hopefully, as people join, we can make it more attractive. So just, okay, I hope my screen is visible. Let me hide this. Okay. Um, so, um, so I'll be talking about a topic that I've been working on for the past few months, and the things how about what I've identified and what I've learned in the past few weeks or leading up to this learning process. Now, before I start, a bit about me. I've been in the IT industry for about 14 years. Primarily, last decade was spent in the data science, building machine learning models, and doing a lot of visualization work at a healthcare company in Singapore. And then I realized during this process that I was also doing a lot of work in the information security team. It might be interesting, some of the models that I've built for the information security team. Things had to be conceptualized from scratch because there were no best practices in the information security space. But leading up to the work there, I found a lot of interest in the security space, and I wanted to specialize using machine learning and artificial intelligence in the security space. I moved to US last year, and I finished a cybersecurity analytics program in Colorado. And yeah, so that's a bit about me. After I finished my graduation, I've been working on a series of articles. I think, Satish and CSA Forum helped publish one of them, which was peer reviewed. And I got a very good response from that, which is what I'm talking about today. The basic point is, when every time I bring this discussion up and talking about cybersecurity in the context of cybersecurity, there is always a good discussion about why is machine learning relevant and where are you supposed to, where should we use it on a day-to-day operations. It might come as a surprise to many, but the very first machine learning model that I've built when working for the cybersecurity team at my previous organization was when an anti-phishing campaign was actually being run in the company. Basically, there was a lot of internal phishing or test phishing emails that were being sent to see how people react to these emails. Clicking on these unidentified links, opening the attachments they shouldn't, not recognizing malicious emails, not recognizing the external emails from the organization, which tend to deceive the names of employees, etc. So one of the earliest machine learning models that I built was classifying, based on the data that we had aggregated as a part of these test campaigns. We built a machine learning model to classify who are at the biggest risk in terms of being or the most vulnerable to a phishing attack in the organization. Now, when I say who, it wasn't necessarily like what were the biggest factors. Was it the tenure? Was it their job function? Was it the kind of role they were in? Was it also like were they remote employees, etc.? And what it kind of helped is the initiative was really successful in terms because the company was able to plan a very targeted customer, or the user training programs, like very customized training plans to help people understand what phishing is and be aware of those scenarios. Now, starting with something like that, it could be used in pretty much a day-to-day or a regular operational task like threat classification. Now, when I started writing this article, creating a threat classification model. How do you create a good threat classification model? Now, there are two things. Generally, when in the data science space, when you talk about machine learning, um, you tend so let's say that consider the example of using net flow data. We have net flows captured, and you can, with good likelihood, predict whether a certain traffic indicates the likelihood of an attack or not. A simple binary classification. Is it a one? Is it likely an attack, or is it normal traffic? And I think that's something that can be done fairly well, and fairly efficiently, using a lot of the best practices that are available in the market. But what really complicates is when you're trying to create something for a multi-level label classification, which is like trying to predict the type of attack based on the net flow data, which is what my article focuses on, and what are the challenges that we'll generally see during this process. Now, the biggest challenge is,
Yamnish,
huh?
sorry to interrupt you. One question. As you were sampling the data, was your sampling was limited to only NetFlow, or you were looking into cloud-based network logs like VPC flow logs and others as well?
No, just the net flow data. I think one. So even within the net flow data, I was actually
Hmm.
using a test data set that was, I think, University of Australia. They had captured a live scenario where they had introduced bots and different types of attacks that were simulated, and they captured this data. Now, the data itself was 30 million rows of data, which was really high, or which was it was a heavy data size. And for me, someone who's actually building, I was just trying to think of my previous work scenario. What were the resources that are typically available to a regular data scientist? Okay, I have a GPU, and I have a certain GPU, and I have, sometimes I even run a sample set of that on my local machine. I was taking care of both, the hardware restrictions that are available, I mean, that are generally applicable to any data scientist within an organization. And I realized a good way of sampling the data is actually required, which means if I'm actually training my machine learning model for the first time, I actually started using a Tesla GPU, and I still could not train even like 10 million rows of data, because netflow data tend to be very high in size, because the frequency of data generations is very high in the security context. And which is why I think, when I was focusing in the article, I wrote about stratified sampling. Stratified sampling talks about sampling the data which is representative of the actual data set, that of your entire data set. You do take a sample. Let's say if you want to start modeling on 100,000 rows, or 500,000 rows of data, but you take it in such a way that it is very much representative of the actual proportion of the net flow traffic. And that is a good starting point, because traditionally, like when you trying to start training a model, you do not have the luxury of using all 30 million rows of data, and that could be a good training point, starting point. And the class imbalance problem, this is pretty much applicable to any particular domain, but why it becomes even more significant or even more challenging in the security context is, most traffic in most of the traffic is normal, and a very small significant or a minor segment of the traffic is can be classified into an attack. What that means is, when a machine learning model tries to learn patterns from the data, there is a high likelihood that it tries to lean towards the majority observations and ignore anything that is like very minor in terms of nature. And so a couple of techniques, that could be handle this imbalance are, you could take an approach of using a SMOTE technique, or a weighted approach technique. I do not want to get to the math of it. I'll share the link to the article, but the article focuses on these two techniques, which could help avoid that class imbalance. And another aspect of general data science that could be actually like very carefully implemented to security data is the concept of feature selection. Now, generally there is I think, as most data scientists, I think, people generally do not like when I just put it out there and say, in a security context, if two features are highly correlated, there is no need for you to actually remove them from the modeling process. And when I say this as a general statement, it is very controversial in that context, because what I realized is, especially when building a model to classify what kind of attack, using the net flow data, every minute detail becomes very important in terms of how your algorithm, how your model is actually created. Now, let's say there are two features, like, there is a size of the packet and there is the number of packets. Generally, like if you look at these two features in the data, these are always highly correlated. But, if you just go by the book and say delete one of those because I have all my information I need, so you need to drop one of these because these are highly correlated and they provide me the same information. They may not be able to predict, classify attacks such as like, denial of service, etc., where one feature provides some information, the other cannot. And this is exactly where domain knowledge becomes highly significant. And that is where you need to look at every single feature, even though it highly correlates. And before you even drop it, without giving it a thought. I mean, so that's why it becomes largely more important. And it becomes significant because of the class imbalance problem that highly exists in the NetFlow data. And another aspect of this is I also, what I spoke about in the article is also the explainability aspect of things. Now, when generally, I'll just quickly highlight in the interest of time the machine article that I have. So explainability is something that is generally not always included in a machine learning model process. Sometimes, the focus is on getting the right models to work with. But in the context of security, I think for every particular data point, whether it is predicted as, okay, class 2 DOS attack or not, it is important to understand what led to that conclusion. And in the article that I've created, I've kind of highlighted what exactly and how exactly do you build this, and how do you interpret that. So this is something that I focused on. Now, yeah, so I mean, I just want to stop there and actually like see if anyone has any questions before I get into the detail. But before I actually, there's a link to the article which I'll also be sharing in the chat. But what I'm also wanting to see is if the next steps for me is actually I'm working on a couple of other articles. I think a classic machine learning use case in security is looking at anomaly detection. There are various different anomaly detection techniques. Most it's called it's basically it's unsupervised. So how do you select which one is the right unsupervised or technique, or which one is the better technique? And I also focus a bit about that in terms of classification, looking at only ensemble techniques. Why are they a good starting point, and why and the why aspect of it. So I think what I'm basically trying to create or explore at this phase as I look for my next role is create these set of kind of a best practices which largely do not exist in the context of security space. I always look up to professionals like Patrick, the work that they have done for the EPSS. I'm excited to hear because I think I look at his content and the visualization aspect of things pretty regularly. And I'm pretty excited at how that work is progressing. And likewise, what I want to do is, look at all the existing developments in the market. There is so much of work being done in the deep learning space. There are language models. My next article that I'm actually working on is like I said, one of them is focused on looking at the different anomaly detections and see which can be used at what context and what could give you the results, and what should be your decision making points. And the second aspect of it is a pretty resource intensive one, which is looking at the large language models. I actually want to start with transformer based models like the even like BERT, etc. And not even get to GPT or things like that as early. But I want to see how those capabilities can help in the context of security. Some of these are from my own personal brainstorming, and some when I was actually like brainstorming with professionals, etc. But I want to see if there is anyone interest in collaborating from this forum, or anyone that you know who would want to work on this. And I want to continue working on publishing more articles as things progress. So happy to collaborate or or connect virtually, and then take it from there if anyone is interested in some of the work that I'm doing. And please do give the article a read. It is pretty long, but I think I've tried to detail and give it like one single source of reference for the kind of challenges that you would see building a machine learning model, specifically in the context of security. So hopefully that helps, and not too confusing. So happy to take any questions.
No, I think this is a great stuff, Yamnish, and I would like to give an opportunity to others to talk, ask any questions before I chime in.
Mhm.
Okay, maybe I can chime in then.
Yeah.
Yeah, so I think this is a very good start. So, based on my experience, I will tell you one thing. One of the thing in the security industry we always look for is something called as a correlation,
Mhm.
right? So good that you started with a net flow or a VPC flow logs, which gives network level visibility.
Mhm.
I think next steps I would recommend is maybe tap into maybe AWS or GCP logs, uh, get into the network logs as well as VPC flow logs,
Mhm.
and then along with that, as you build your model, correlate that with access logs
Mhm.
and see how can your model correlate access logs, VPC flow logs, and your net flow logs. Now, if somebody is using a hybrid environment, hybrid cloud environment, which is a combination of private and public, then
Mhm.
all three correlation point will be very useful.
Right.
And I will tell you, this is one of the fundamental problem we have in the security industry.
Mhm.
I mean, I am in security industry almost 17 years now. I have not seen a solution which can give me one-on-one visibility on end-to-end kill chain.
Mhm.
Well, if you are using some third-party tool, sure, they will tell you process level and all that stuff. But from an anomaly detection point, I am yet to see that end-to-end visibility. That's number one. And even the correlation of the kill chain all the way from how it started, how it propagated, and how it ended,
Mhm.
even from the model perspective, I think that is another area to explore. And great. Well,
Yeah.
thanks, Amnish. Yeah, no
Yes.
problem.
Thanks, Suresh. Yeah. Thanks, everyone. Yeah.
Yeah.
Yeah.